In this video, we shall look at integration of irrational functions. Now, a rational function is a function that can be reduced to a rational fraction. An rational fraction is a fraction whose numerator and denominator are polynomials, such as this one. So this integrand has a numerator of 1 and denominator of a quadratic function. So this is indeed a rational fraction. Before proceeding with the integration of this rational function, let's rewrite the denominator in the following manner. First, by factoring out the a, you get a times x squared plus b over a x plus c over a. Now this term can be further rephrased by completing the square of the terms in the square bracket, in the curly bracket. And that's going to give you x plus b over 2a squared plus 4ac minus b squared over 4a squared. And so, this integral can be rewritten in the following manner. 1 over a dx over x plus b over 2a squared plus 4ac minus b squared over 4a squared bracket. 3 cases may arise for this integral, and we shall look at them, each of them, separately. So the first case is when a is positive and 4ac minus b squared is also positive. So now, if you let the quantity in the first bracket x plus b over 2a to be, let's say, u, a new variable, and the second term here, the 4ac minus b squared over 4a squared, to be, let's say, k squared, then this integral will simply become du over u squared plus k squared. And this, we know, is one of those standard integrals for which the solution is 1 over a. So 1 over a is simply that term. K arctangent u over k, where u is defined by that, x plus b over 2a, and k squared is given by this entire term, 4ac minus b squared over 4a squared. And that gives the solution to this first case. Now, case 2 is when a is again positive, but 4ac minus b squared now is negative. Now, defining a new variable u as before, which is x plus b over 2a, and k squared now, which is a positive number, is defined as b squared minus a 4ac over 4a squared. Then this integral here can be rewritten in terms of standard form, so which is just du u squared minus k squared. The answer for this integral, which is of standard form, is simply 1 over 2k natural log u minus k over u plus k. So together for case 2, the final answer will be 2ak, a from there, natural log u minus k over u plus k. And this is the result for case number 2. U is defined like that, and k follows that expression. Finally, case 3. Case 3 is when a is negative and 4ac minus b squared is negative, as for the second case. So as before, we defined u, a new variable, to be x plus b over a, and k squared to be b squared minus 4ac over 4a squared. Since for this case a is negative, I'm going to write 1 over a as quite simply 1 over minus magnitude of a du over u squared minus k squared. Now bringing the negative inside the integral sign, you will get 1 over magnitude of a du over k squared minus u squared. And the result for this integral is 1 over 2k natural log k plus u over k minus u, which then yields 1 over 2 magnitude of a times k, where k squared is defined by that, natural log k plus u over k minus u, and u is defined by that variable. And that gives us the result for case number 3. As an application of the things that we have discussed thus far, let's look at the following integral. To determine which of the 3 cases that this integral belongs to, let's rewrite as we did before. Let's first factor out the 2. So it's going to be 1/2 integral dx x squared plus 3 over 2x plus 4. Now if we want to complete the square, as we did before, so we have x plus 3 over 4 squared plus 55 over 16. So that is the result after completing the square. Now this is obviously case 1. Now how do we know it's case 1? Well, a is 2, which is positive, and 4ac minus b squared is 55. So this is a, this is b, this is c, so you can compute 4ac minus b squared, and it turns out to be 55, as shown here. So that means we have case 1 here. Using this result that we wrote down a few minutes ago, then the integral can be solved to give quite simply 1 over 2. K is that square root 55 over 4. Arctangent u is this entire x plus 3 over 4 over k. K is again square root 55 over 4. After some simplification, for example, this becomes 2, and if you multiply the terms in the bracket up and down by 4 and 4, then it simply becomes 2 over square root 55 arctangent 4x plus 3 over square root 55. And that is the answer for this integral. So in this example, as you can see, a is 3, so that is positive. Now 4ac minus b squared is 4 times 3 times 2 minus 6 squared, and that's going to be 24 minus 36. So that's a negative. So that means this integral belongs to case number 2. Rewriting this integral, one get, just like before, you factor out the 3 and then you complete the square. You will end up with x minus 1 squared minus 1 over square root 3 squared. Remember this results that we arrived at a few minutes ago? Now we're going to apply this to this integral, and you will get 1 over 2. A is 3 from here. K is 1 over square root 3. Natural log. U is x minus 1. And K is again 1 over square root 3. Over U, x minus 1 plus 1 over square root 3. Simplifying this, we get square root 3 over 6, natural log 3x minus 3 minus square root 3 over 3x minus 3 plus square root 3. And that solves the second integral. Now, integral 3. You can see that a is negative, namely minus 2, and 4ac minus b squared is 4 times minus 2, c is 4, minus b squared minus 5 squared, that is, and this is obviously negative, so that means we are dealing with case 3. By rewriting this in the completing the square form, you get 1 over 2 dx over square root 57 over 4 squared minus x minus 5 over 4 squared. Now remember the result that we derived before. By applying this directly to this integral, we will obtain 1 over 2, the absolute value of a, so a is minus 2, so the absolute value of a is 2. Now what is k? K is square root 57 over 4, natural log square root 57 over 4 plus u. U is x minus 5 over 4, and over square root 57 over 4 minus u. Minus u is minus x plus 5 over 4. So here the 4 will cancel, and the quantity in the bracket can be simplified further to give the following answer, which is the final answer for the integral. 1 over square root 57 natural log square root 57 plus 4x minus 5 over square root 57 minus 4x plus 5. And this is the answer to this integral and solves the problem. In all the 3 examples presented, the quadratic denominator does not factorize, and this will in general be the case. Now, if the quadratic denominator factorizes, it is usually easier to do these integrals using partial fractions method. Thank you for watching.